Hello, and thank you for joining me today. This is a 2017 Midwest Animal Science Association presentation. Today we're going to be discussing the effects of increasing copper from tribasic copper chloride or a copper chelate on growth performance of nursery pigs. So today many U.S. swine nutritionists will typically formulate nursery pig diets to contain as low as 11 and as high as 250 milligrams per kilogram of copper, despite the NRC 2012 actually has a copper requirement estimate of only 6 milligrams per kilogram. The increased pig performance has been associated with feeding high levels of added copper. This is typically observed through increased feed intake and as a result, the increased average daily gain. And traditionally, copper sulfate has been the most common copper source included in swine diets. Other sources are available, and those have been shown to actually be more bioavailable to the young pig. So tribasic copper chloride is a hydroxy trace mineral source that is believed to be non-hygroscopic, has high solubility in acidic conditions, but low solubility in water. Then there's alternatively a copper chelate, which is considered to be an organic mineral source. This has been shown to be more bioavailable due to the decreased binding activity with other dietary constituents. To our knowledge, no other data have been published that have directly compared the effects of increasing copper from either tribasic copper chloride or the copper chelate on growth performance of nursery pigs. Thus, the objective of our experiment was to determine the effects of increasing copper from tribasic copper chloride or a copper chelate on growth performance of nursery pigs. A total of 665 pigs were used in this experiment. Group 1 would have contained 350 barrows, initially 6.4 kilogram of body weight. These pigs would have been weaned at approximately 21 days of age. And these would have been allotted to pen based on initial body weight with 5 pigs per pen. In Group 2, this would have contained 315 pigs, initially 5.2 kilogram of body weight, were weaned at approximately 21 days of age and allotted to pen based on initial body weight and age. Age block 1 would have consisted of 4 replications per treatment, and age block 2 consisted of 5 replications per treatment. Now the age blocks came about as we did experience a larger farrowing window than what we had previously anticipated. Groups 1 and 2 were fed a common starter diet for 7 and 5 days respectively. And this common starter diet would contain 17 milligrams per kilogram of copper from copper sulfate. And this would have been coming in from the trace mineral premix. At the beginning of the trial, pens were allotted by body weight to one of 7 dietary treatments, 10 replications per treatment in Group 1, and 9 replications per treatment in Group 2. So these treatment diets, I want to take a moment and walk through them with you. We would have used a control, which would have contained the 17 milligrams per kilogram of copper from copper sulfate in the form of the trace mineral premix. We would have had a control plus 75, 150, or 225 milligrams per kilogram of copper from either tribasic copper chloride or the copper chelate. Treatment diets were corn, soybean meal based and fed in meal form in 2 different phases. And these 2 phases would have lasted from days 0 to 14 and 14 to 35. Pigs and feeders were weighed every 7 days to calculate their performance of being average daily gain, feed intake, and feed efficiency. I'll want to take a moment and go through the diet composition with you. Across the top of this table, we have dietary phases 1 and 2. And then along our left-hand margin, we have our ingredient on a percentage basis. Now these were corn, soybean meal-based diets with 10% dried whey in phase 1, added fat in phases 1 and 2, a specialty protein in phase 1. And then we have our supplemental vitamins and trace mineral premix. And this trace mineral premix inclusion would have been held constant across each treatment within each phase. Our supplemental macrominerals, supplemental amino acids, and our copper source. The MHA is our methionine source for amino acids, and the activity level in the Mintrex product or in the copper chelate product would have been accounted for in our dietary or in our diet formulation. Here I want to share with you the calculated analysis for phases 1 and 2. Along our left-hand margin, we have our SID amino acids, and these amino acids, we would have provided supplemental amino acids. In the ratios, these amino acid ratios would have been balanced across treatments within each phase. So the data were combined and analyzed as a randomized complete block design using the Glemix procedure of ASAS, with pen as the experimental unit, treatment as the fixed effect, and group and block within group as the random effects in the model. The main effects of copper source and level, as well as their interaction, were considered significant at p less than 0.05 and marginally significant when p fell between greater than 0.05 and less than 0.10. Now I'll take a moment to set up the slide with you. All of our results slide from this point forward will be set up in a similar manner. So we'll have average daily gain in this case, or in other cases, our performance measurement along our y-axis. Across our x-axis at the bottom, we have our added copper ranging from 0 to 225 milligrams per kilogram of copper from either tribasic copper chloride or our copper chelate. Then I will discuss the statistics in terms of main effects of copper level and copper source, and when appropriate, the interaction thereof. So for average daily gain from day 0 to 14, as we increase copper from 0 through 225 milligrams per kilogram, average daily gain increased. We were unable to detect a copper source effect, with means ranging from 235 to 266 grams per day. For average daily feed intake, days 0 to 14, as we increase copper from 0 through 225 milligrams per kilogram, average daily feed intake increased, with no difference for copper source and no interaction thereof for level and source, with means ranging from 307 to 350 milligrams per kilogram. For feed efficiency from day 0 to 14, we were unable to detect a copper level or copper source effect, with means ranging from 0.740 to 0.785. For day 14 body weight, as we increase copper from 0 through 225 milligrams per kilogram, day 14 body weight increased. There were no differences for copper source in this particular instance. Now looking at the phase 2 data, average daily gain, this would be days 14 through 35, and correspond to a body weight of 9.4 to 21.1. We did not observe a copper level or copper source effect, with means ranging from 561 to 590 grams per day. For average daily feed intake, day 14 to 35, similarly did not observe a copper level or copper source effect, with means ranging from 837 to 870 grams per day. Interestingly, although we did not observe any differences for average daily gain or average daily feed intake, as we increase copper from 0 through 225 milligrams per kilogram, feed efficiency actually improved. Now we're going to look at the overall data. This would be day 0 to 35, corresponding from body weight from 5.8 to 21.1 kilograms. As we increase copper from 0 through 225 milligrams per kilogram, average daily gain increased, and we were unable to detect any differences for copper source. For average daily feed intake overall, there were no differences for copper level or copper source, with means ranging from 629 to 660 grams per day. Now looking at overall feed efficiency, as we increase copper from 0 through 225 milligrams per kilogram, feed efficiency tended tended to be improved, with no differences in copper source, and there was no source by level interaction either. These means would have ranged from 0.677 to 0.701 for overall feed efficiency. For ending day 35 body weight, as we increase copper from 0 through 225 milligrams per kilogram, day 35 or ending body weight increased similarly, with no differences in copper source. So in summary, overall, from day 0 to 35, we did not observe any interactions for copper source or level, and average daily gain in ending body weight increased as copper level increased. Because average daily feed intake was relatively unchanged, the feed efficiency tended to be improved as copper level increased. In this experiment, we did not detect any differences between copper sources for overall growth performance, and from this particular study, it is unknown if increasing copper above 225 milligrams per kilogram would further improve growth of these nursery pigs. Thank you to Micronutrients for your partial support in this experiment.